Okay. We will start with last 3 classes we discussed basic techniques. Okay. Basic techniques is lambda, S, US, and RS, and for radius. So where we discussed various customer oriented and blue oriented approaches. EMS, that is also radial system. Radial system is where we have a single feeder, we have various distributors for the different load points. Today we will discuss with mesh networks. So what is the characteristics of reliability evaluation of mesh networks? One method that can be used to evaluate the reliability of continuously operated system is based on construction of state space diagram. Power systems are continuously operating systems. What is the other type of reliability system?
Sir, see last one brother sir. No, sir. See, last one.
Okay. So what is the continuously operated system? Power systems are continuously operated systems. Okay. What is the other type of systems? What is the other type of system? Mission oriented. Right. Where, for example, flight starts, it should reach the destination. Mission, it should never fail, cannot fail. Okay. Whereas for continuously operated systems like power systems, some kind of failure is accepted, and we are just trying to find out the reliability or the failure rate of such a system. So we do that by means of state space diagram. That means how many such failure conditions are possible based on the feeders and distributors. Also, this method is accurate. It becomes infeasible for large distribution because state space becomes very large, or very large dimension, very cumbersome. However, it can be used as the primary evaluation method in several applications. Secondly, it is frequently used as a means of reducing approximate evaluation techniques. Thirdly, it is extremely useful as a standard evaluation method against which accuracy of approximate methods can be compared. So, you can go for detailed state space approach. That is one approach. You can write down. One approach is the state space approach. Okay. One approach is the state space approach, which involves large number of states. Okay. One approach is the state space approach, which involves large number of states. The alternative method is to use approximate techniques. The alternative method is point number 2. The alternative is to use approximate techniques, okay, which use reduced state space models. Okay. Which use reduced state space models. Okay. Next, draw this diagram. This is a typical mesh network with only one mesh. Okay. Whereas in normal mesh network there will be large number of meshes. But we will start with the simple diagram. This is from the reliability bulletin board. So this is a typical mesh network. It is a dual feeder system. Feeder 1, feeder 2. Assuming that the two bus bars and the circuit breakers are 100% reliable. So this bus bar component 5 and 6 and component 7, 8, 9 and 10, these are 100% reliable. So, okay. So bus bars are 5 and 6 and circuit breakers these are 100% reliable. Therefore, the reliability of the system is covered by two lines, 1 and 2. So, reliability is computed for components 1 and 2, that is the lines, and the transformers 3 and 4. So, in this case, we are assuming the bus bars are generally reliable. Copper bars, so these are very reliable. Circuit breakers are also reliable. It is relays which are not reliable, that, but circuit breakers are also reliable. Okay. So how many components are there for which we are going to evaluate reliability? How many components are there? कितना component reliability हम बात करें? ठीक है, चल 4. So we have 4 components for which we need to find out the reliability. Now here each component can be either up or down, 2 states. So since each component can have 2 states, so there are total 16 states. So since each component has 2 states, so in total there will be 16 system states to consider. And these 2 states are up and down. Up and down states. Okay. Okay. यदि हमें सेवड़ा को don't consider that reliable. So what is the total number of states? 2 into 2 to the power 10. Still larger. So there are 16 states. So we can consider each of the 16 states and find out the reliability. Okay, but it's very difficult. We did not find out that. Okay, the alternative is, as you have written, two methods, approximate methods. So what is the concept of the approximate? An alternative method 2 states the child calculation method based on a set of approximate equations for evaluating failure rate, outage duration, and unavailability. What are these in that? Lambda, U, and R. Okay. So for 2 components in parallel, this is the formula that we need to use. Derivation is not useful. This is the formula. Write down this formula. So for a parallel system, lambda 1, lambda 2, R1 plus R2, 1 plus lambda 1, R1, lambda 2, R2, and this can be approximated to lambda 1, lambda 2, R1 plus R2. Okay. What is our objective? Our objective is to compute lambda, R and U. So first equation is for lambda. First equation is for lambda. Second equation is for R. And the third equation is for U. Okay. So this is for 2 components in parallel. Right. Basic parameters are lambda, U and R that we discussed in the question. For 3 components in parallel, the same approach can be used to compute unit system. Write down all the equations for 2 components in parallel, for 3 components in parallel. example. Consider the reliability data for the components shown in the following table. So compute the load point reliability index. So you have got lambda and r. Using this, you are going to compute all this. So write down the values. So there are 4 components which we are considering to be unreliable and hence to be used for reliability evaluation for the power parallel distributed system. These are the lambda and r values. R is the repair time of this type, repair rate of the outage. The network reduction method creates a sequence of equivalent components obtained by gradually combining series and parallel components. In this case, combine components 1 and 3 in series, 2 and 4 in parallel, and finally compute these 2 equivalent components in parallel. If you want to series, if 1 and 3 are in series, that means you are going to use those equations RS, US and lambda S. Adding. Right? हमने 1 3 है सारा equivalent lambda हो 0.5 plus 0.7 and 2 और 4 equivalent lambda is 0.5 plus 0.0. हमने series में कंसिडर करो. Okay, it is also shown here. 1 and 3 are in series. 2 and 4 are in series. These are series component in series equations. But those combination is in parallel. So then you are going to use this equation. This one, 2 components in parallel. So this time it becomes 2 components in parallel because we have combined 2 in series and 2 in series. So total 2 components in parallel. So these equations can be used. We solve it later. Can you write the values? So this is also solved in here. Let's solve it manually also. We add here all this. So we'll go to that after some time. Now we'll discuss something else. So next is failure modes and did you write this? Did you write this too? Is it clear? You will not write the first line, just write the second line. In this case, combine these 2 components, okay, as series systems, then find out the reliability as both in parallel. Okay. That is the approach. It is solved in nice and simple, or you can do that manually also. Next is failure mode and effects analysis. So this is the third type. The first one was complete state space diagram of the system. Second one was approximate methods where you use reduced. You will reduce the network reduction. Series parallel, network reduction. The third one is failure modes and effect analysis. Okay. So what are the modes in which a system will fail? You will focus on that only. The failure modes are directly related to the minimal cut sets of the system and therefore these can be used to identify the failure modes. So you have not read the cut set, that is a typical reliability engineering approach. Okay, cut set method. Just know the name, need not go into the detail. Okay, so detailed analysis can be used by finding the minimal cut sets. Okay. It should however be noted that formal application of minimal cut set algorithm is not always necessary. Since it is often possible to identify failure mode for most systems from a visual inspection. So rather than doing a cut set analysis, we use by visual inspection. By inspection, you can tell, okay, this is how the system can fail. For example, you just do a walk through of the whole VLCC network. Okay, then you can identify, okay, this is the point that may fail because here the system has been very old and weak. So that is one failure mode. Okay. Okay. So failure modes are therefore defined as overlapping outages. Okay. So we can, rather than one way, these failure modes how they can be obtained. One is cut sets. The second one is visual inspection. Okay. So therefore these modes are known as overlapping outages, and associated outage can be defined as the overlapping outages. So many failure modes can overlap. Each overlapping outage is effectively a set of parallel elements, and its effect can be corrected using the equations for parallel components. So that is how so failure modes can be considered as parallel events, and accordingly you can define the reliability. Also, since each of these overlapping outages will cause a system failure, these are effectively series to form a reliability point of view. Okay, so all such failure modes combined can be added in series with some other failure modes combined. System indicators can therefore be evaluated by applying the equations in series component in order to combine all the overlap components. So this is how failure modes can be utilized. So for failure modes, one such example is there from the book. So write down these three equations. It should be noted that the value of the system unreliability is evaluated using this summation rule. Okay. When you have so many failure modes combined, so you can use. So individual such parallel failure modes you can consider, then you can combine them in series. Write down. An appraisal of the results show that considerably more information is given by the failure modes approach. So it is one of the best approaches for evaluating meshed networks. For instance, in the present example, the results show that the system failure rate and unavailability are mainly due to the overlapping post outage of the two lines, but that the system outage duration is mainly due to overlapping to transformers. So outage is proportional to transformers, whereas the failure rate is due to lines. Okay. So these are two different failure modes. One is due to the lines, one is due to the transformers. The information is not readily detected from the network reduction method, particularly when the systems are integrated. So we cannot just reduce the system and find out using simple parallel approach. We have to use the failure modes approach. Really clear?
Yes.
Next is, so far we considered, as you said, bus bar to be 100% reliable. Now what if bus bars are not reliable? Bus bars are very reliable. These are mostly copper bars. What wrong can go? So those are mostly reliable. But what if we need to include a bus bar failure? Failure of breakers and bus bars can be taken into consideration using both network reduction and failure mode. You can use that. You can see from the result that load point reliability is dominated by the failure of the two bus bars. So if the bus bars fail, everything fails. This is expected because the two components are series components and therefore counteract much of the benefit provided by the redundancy. So even though you have provided the parallel branches and redundancy means what? You have provided two paths. One path fails, you can take the power in the other path from the other path. But what if the bus bar fails? Both systems fail. Okay, everything fails. Recognition of series components can be an important aspect in system design because their liquidity causes the dominant role. However, the contribution depends on the reliability such as the bus bar. Bus bar is in series with both this. This is a parallel system. Bus bar is in series with that system. Okay. Thus, if the failure rate of each bus bar is very small compared to that of the parallel branches, contribution by the parallel branches would still be significant. Next. This is one example related to the bus bar. Assume that the bus bars of the reliability data are shown below. Okay. So in this case, the same equations can again be used by after inclusion of the bus bar. So these are the additional failure modes, minimal facets are component 5 and component 6. Which are 5, 6 are what are the 5, 6? Lines, right? Lines. So those are another failure modes. Okay, that can also be counted. 5 is the bus bar. 1 to 9. So now we will see one problem, one by one the problem we will see. Okay. So this is the first problem we will see. This problem we will see. figure 8.1 means that parallel diagram, that is figure 8.1. The parallel diagram, that is figure 8.1. 7.1, 7.2, 7.3 means the initial three equations, because in radial system is chapter 7 in the book. Okay. 8.1, 8.2, 8.3 means for the parallel system. So three component, two component, that is 8.1, 8.2, 8.3 from the book. I have given the book reference if somebody wants to refer to the book. Okay. And this is the first problem. Second problem is final modes. Third problem is using bus bars. Okay. So this is actually a partial solution. Full solution I have not provided. So you start with solving the basic, the first part. So we'll solve it now.